Welcome back. Longest substring without repeating characters. Let's get started. Okay, so given a string, find the length of the longest substring without repeating characters. First example is ABC, ABC, BB. Output is 3. Answer is AB. I was going to say AB3. Answer is ABC with the length of 3. Or it could be CAB. Or it could be, yeah, it could be CAB, right? So B, 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 output is 1, answer is B, with the length of 1. P, W, W, K, E, W. Output is 3 because, you have the K, W, K, E, or K, E, W. Note that the answer must be a substring. P, W, K, E is a subsequence and not a substring. Okay, so this is a very, I guess this is a very straightforward, typical sliding window problem. So let's take a look at the first example. When we are, so sliding window being, we use a window, kind of like a sliding window, to go through the string. And this window is, this window has a substring that meets the requirement of the question. And as soon as we, so while we are iterating, while we are advancing on the string, as soon as we meet a character that makes this slide window not meet the requirement, then we will move the head. Sorry, the camera right now is in mirror mode, so what I'm doing, this is my left right now. So whenever we meet a character that makes the string not meet the requirement, we'll remove the head until the requirement is met again, and then we'll keep advancing the window. So now, how do we construct this slide window? Sorry, I just had a really full dinner. Okay, so then how do we construct this sliding window? Now what I'm thinking right now is maybe we can use a deck. Now deck is a double linked list. So whenever we see a character that meets the requirement, we can add it to the end of the deck. And while we are adding characters to the deck, we also need a set to keep track of the characters that we have already iterated through within this sliding window. So while we're advancing on the string, we'll check if this character is contained in a set. If not, that means that this sliding window still hasn't had this character yet. So yes, we'll add it to the sliding window. And but if the set does contain this character, that means that if we keep advancing through this character, this sliding window won't meet the requirement anymore. So we will include this character, but at the same time, we'll also move the header to the index right after the first occurrence of this character. So I think this will work. Without further ado, let's do this. So first of all, like I said, we need two data structures. So first is a set. God damn it, this keyboard. Hold up. Okay, so first is that we need a set. Let's just call it set and new hash set, and this will be an integer. Okay, and also we need a deck. Now deck is an interface. Wait, hold up. Deck should be a character. So let's call it, well, let's just call it deck. It's new, or we can just call it Q. Deck, is this first in, first out? No, this is not first in, first out. Wait, actually, it is a first in, first out, right? So, hold on. Instead of you implement a deck, we can just use a queue. So, whenever we add a character, let me think about this. So A, B, C, and then we want to keep. So A is first, and then B second, and then C. And then if we want to take out, also this is a queue. Okay. So Q is, so this was equal to linked list integer. By the way, Q is an interface, right? I need to make sure. I haven't used Q for a while. Jesus. Java 8. Compile the Q. Q implementation. Interface Q. All normally implementing class. Array Q, linked list. Okay, linked list is in contain. Okay. Alright. That's good. Okay, so now now it's time for us to iterating through this string. So first of all, we need to have a variable to keep track of the maximum length. So I'll call it max length is equal to 0. And then we'll start iterating. So here's the thing. I don't know if car at it's actually, if we do car at n, I'm wondering if we do car at this, is this going through n characters to reach the character at n index, or it doesn't go. So my question is, when we do car at n, is the time complexity big over n, or it's a constant time? This is I'm curious about this, because it depends on how if I wanted to use the char at or just convert the string to a character array. So I've been wondering about the implementation of this. Okay, for string buffer is a constant time operation. Okay. I see. For string char at is a constant time. So this is good lesson to learn. Okay, so this is constant time. Interesting. Okay, good to know. So for I is equal to I less than s dot length and I plus plus. Okay. So first of all, we'll need to get the character. We have to get this character, and so int is equal, ch is equal to s dot char at. So this is the question I was wondering, because I don't want to go through the string to get a character. Okay, so character. So first of all, we need to check now if this character is contained in the set or not. So first of all, the set contains this, right? Now set should also be a character. I don't know why I was thinking of integer. I'm nervous. Okay, give me a break. So set first of all, if set contains this character, then now if now it's time, right? It's time to get rid of the extra, uh, so it's time to get rid of the extra characters that we don't want. So actually, we can do while set contains this, then we can keep polling arrays. Sorry, we can keep polling elements characters out of this queue. So queue dot poll, and then we'll also don't forget that we need to do one more thing, is that we need to remove those elements from the set. Okay, so now set so right now set doesn't contain this character. Now it's safe to add this. So we'll have set add this character, and then queue will also offer this character. And then we'll see the size of the queue. So max length is equal to math max max length queue dot size. And then after we have compared the max length, we'll advance to the next character. So here we'll return max length, right? Okay, so set, well, a set and a queue. Why do I have a linked lists? So we have a set and queue, and then we'll have a max length, which is 0. And then for each character, while set doesn't contain, while set contains this, we will. So first of all, we'll pull a elements from the queue, and then remove the pulled element from the set, and then we'll add this character to the set and offer this character to the queue, and then compare the size. Okay. No suitable master found. Set add is it because that why am I doing int 3 okay, so I guess this will work. Let's see if A B B C, and then we have okay, eleven. Okay, so looks about right. Let's see if that's will pass. Accepted. Okay, perfect. How much time we have that? Oh, it's less than 15 minutes. But this is a medium question. Wow, I have 3.9 million submissions. 3.9 million people have done this question. God, which means half of the population in Hong Kong have done this question, which means the entire city of Seattle has done this question. Now you see how competitive this job market is. All right, so can we do better than this? Can we do better than this? I think yes. I think right here, right now, my queue is a little bit abundant. I think because I was just trying to come up a quick solution. So I didn't want to get into too. I didn't want to spend too much time on calculating the index. But I think with some trick with the indices, I think we can save this queue. So what I'm thinking right now is that can we instead of having a queue, can we keep track of just two indices, right? So one for the head and the other for the end, right? So we'll have something like, okay, so start is equal to 0, end is equal to 0, and then well set doesn't contain this, right? Uh, so so if set so if set doesn't contain this, then we will add this. So we start from the first element. If set doesn't contain this character, now first of all we will add this character to the set, right? And then we will update the head. We'll update the head for this character. So head. So right now head would be like 0, and then we meet another character if it doesn't contain in the set, and then we'll increase the head again. So what I'm talking about head is like the head of the head is what we use to advance through the string. So head, well I guess I call it end this way because we are used to reading from left to right. So I'll call head in the beginning, and then end is what we use to advance through the string. So if the second character it's not contained in the set, then we will advance the end index. So okay, so right now it works. If we keep meeting different characters, we'll keep advancing the head, and at the same time, we'll compare the head. We'll use head minus end. We'll use end minus head, the difference of end and head, to compare the max length. Now, what if we meet a character that is contained? That is, what if we meet the character that is contained in the substring? Then, so now we have met. Now we have met this character that is contained in the substring. We know that it's already existing there. So the head index will keep advancing until we meet that character, and then we'll increase 1. Okay, I think this is doable. So we'll have let's say a head is equal to 0 and end is equal to 0. While set contains this. Okay, so we meet this, then while set contains ch, then first of all we'll need to we'll get rid of the characters before we'll need to get rid of the characters before this character. So well, it contains this, then we will do set remove s dot char at. head, and then head plus plus. So keep removing this, and now this doesn't work anymore because we don't have a Q. So set remove s.char head plus plus. Now after we have removed the, okay, so head will keep advancing, right? Head will keep advancing until it reaches the character, and then set will be removed by the set. So now the set doesn't contain, okay, the set doesn't contain the character anymore. So we'll add ch to the set, and now we don't have a Q. So head right now it's one index after head right now is one index after the new character that just was added. So instead of doing this, what we will do is we will do end minus head. At the same time, while we add this, we'll advance end plus plus. Okay, so add this end plus plus. Well, actually, do we even need end? Now, in this way, we don't even need end, right? Because end is essentially I. So we don't even need end. Let's get rid of n. And then here will just be I minus head. So let's say if the second character, is different. So head is 0, and let's say AB. So head is 0, set doesn't contain this. We will add the first character to set. Set is A right now. So 0, 0 minus 0, well, the length should plus 1. Okay, 0 minus 0 plus 1 is 1. So 1 is larger than max length. Max length is 1. And then the I advance to the next character. You have B, right? So B doesn't contain, is not contained in the set. Also, we added to the set AB. So now right now the I is 1. So 1 minus 0 plus 1 is 2. So 2. That's correct. So what if we have AA? So A, well, unfortunately, it's contained in the set. So we'll remove this character from the set, and remove this character from the set, and head will be at 1 at this point. So 1 minus the max length, 1 minus 1 plus 1 is 1. So okay. So let me see. $11. Okay, so we even save the Q using the Q. We just keep track of. We just need a set. We just need a set. We don't even need to. Interesting. Okay, let me see if this one works. Accepted. Okay, perfect. So interesting. That's a very interesting question. Yeah, it turned out that you only need a set uh, to resolve this question. If you know any other way, well, this is the best solution I can think of. But if you know a more optimal solution to this question, let me know in the comment section below. I would love to learn. Anyways, thanks for watching, and I'll see you next time.